So my name is Dr. Shamik. I'm from University of Stirling, Khaimah campus. It's located in the United Arab Emirates. I'm working as an associate professor in the Department of Computing Science, and my co-author is Professor Chandrima. She's working in Computing Science Engineering Department as an assistant professor in Dr. Sudhir Chandra Institute of Technology, which is located in Kolkata, India. So my topic is building predictive model for rainfall focused in Australia, and I have used technologies like machine learning over here. So let me start my presentation. So in the introduction, I would like to mention that yes, it's really important to have a prediction in rainfall because rainfall is required for the agriculture, for water management, as well as it's also good for predicting any kind of disaster, which we can manage if we have a prior information to that. And we know that Australian climate is actually a very versatile climate. And we have also done a research on that specific climate. That's what is the backbone of this particular project. And what exactly is the importance of using machine learning whenever you're talking about weather forecasting? Like in my research, it is rainfall prediction. So this is what exactly is my abstract, because as we know that rainfall prediction is very important. And as I already told you, for agriculture, for urban planning, for water resource management, disaster recovery, in all those aspects, it is really, really important. And the accuracy in rainfall prediction is also one of the prime concern of my research work, because it prevents natural calamities like floods, droughts, and at the same point of time, I have made use of Python over here to create some predictive model on this particular aspect. And different categories of pre-processing technique I have used on the raw data set using various categorical variables which has been used in the data set. And I've collected the data set from the official website of Australia for getting an accurate weather prediction. And we have investigated several data, as I already told you, from the meteorological data, and used different algorithms like random forest, decision tree, as well as certain ensemble sophisticated machine learning algorithms. And this particular research has been also advanced in providing a very consistent and solid framework for the rainfall prediction. So the main objective of this particular research work, as I told you, that design and developing a predictive model using machine learning, and the implementation has been done using Python. And the target area is the Australian metropolitan areas, various cities, urban, suburban, as well as the rural areas of Australia, to collect the meteorological data. And extensive comparative analysis has also been done to figure out the accuracy of this particular forecast. So as a literature review, I would like to mention three very important things over here, like the global rainfall prediction studies, which has been done. And what I have seen that there are actually study gap, the research gap, whenever we are talking about the Australian meteorological data and start making use of machine learning strategies over there. So identifying that particular research gap, we move into working on this particular aspect, that let's collect the data from various provinces of Australia, and rigorous data analysis and machine learning strategy ultimately gives us an accurate result of the rainfall prediction. So I'd like to give you a data set overview before we move into the actual research work. So we have collected a massive data set, as you can see, 140,000 rows with 24 distinct features, and we have identified certain key variables like the rainfall, rain today, rain tomorrow, and the risk analysis factor. There were challenges because the data was not very sophisticated. There was missing value. There was skewed pattern which has been observed on the rainfall data. So an extensive pre-processing has been done on this particular data set before we start train the model with this particular data set. Certain characteristics are very important, which has been selected through a heat map, like maximum temperature, minimum temperature, humidity, pressure with respect to a specific time, as you can see over here, 3 p.m., 9 a.m. And we also deal with handling different kinds of missing data, and then followed by we have performed a specific level encoding for the categorical variable. And at the end, the data has been split into train and test. So you can see different type of data visualization which we have obtained as a result of exploratory data analysis. So you can see the distribution card for the minimum temperature, for the maximum temperature, distribution for the humidity, so which we have plot using the Python coding, and Jupyter Notebook has been used as a tool over here to perform the exploratory data analytics. Based on that, we have selected certain standard models, as you can see over here: random forest, logistics regression, support vector machine, as well as decision tree has been selected over here. But ultimately, after analyzing, after doing an evaluation, we start forecasting on a specific model. And obviously, here 20 distinct weather-related features has been incorporated while we have selected a specific type of model. And that's not the least. At the same point of time, we also start enhancing the performance of the model to avoid overfitting and underfitting, because we know that accuracy is one of the prime concern whenever we start predicting a rainfall for any specific country. And as a result of that, we have made use of the grid search, CV process, cross-validation process, and we have tuned different kinds of hyperparameters to improve the performance of that specific model. And at the same point of time, you can see the workflow which has been given over here, that random forest, which is actually giving us a very satisfactory data with an accuracy of 85%. We have also made use of other evaluations parameter like precision, recall, as well as the F1 score. The same strategy has also been applied for the other models, as you can see over here, decision tree, which obtained an accuracy of 78%. So this is what exactly a strong evaluation matrix has been used to figure out the performance of those models. And as I can say, that confusion matrix, one of the strong tool to figure out that what is the percentage of the true positive as well as a false positive, because we would like to find out the deviation between the actual and the predicted data. And that's the reason we have made use of the confusion matrix over here. And ultimately, you can see the result over here, that random forest leading with an accuracy of 85%, followed by logistics regression, decision tree, as well as the support vector machine. So random forest is actually the leading model, and we did an extensive result analysis, as you can see over here, that logistics regression, which is performing much better than any other model. And we have selected two specific criteria over here, two specific class. One is with a no rain class, another is with a rain class. And we started figuring out the performance of each and every model in this particular context. And in conclusion, I would like to say that whenever we are using such a kind of machine learning model, here random forest plays the best result, and we start making the framework by deploying a random forest model in this particular case. In future, we would also like to work with more real complex data using various other geographical features and external climatic conditions to figure out whether our model is actually performing up to a specific level or its performance is getting degraded. Because it's very important in machine learning that whenever a specific model has been selected and deployed over the year, we need to fine-tune that particular model so that it can give its best performance as long as the accuracy of the prediction is concerned. So thank you so much for listening my presentation.